Thanks for coming. I'm a practical guy. I'm a software architect at ABAX in Norway. But this time I will be talking about things that are a little bit less practical because I got annoyed by something. I got annoyed by people oversimplifying problems. That's why I made this talk, but it will be practical examples, so bear with me. I want to start with a simple puzzle. And it's a bit about psychology, so if you know the answer, just shut up. So here we go. Baseball shopping, a bat and a ball cost together $1.10, and the bat costs $1 more than a ball. And how much does the ball cost? Who thinks it's 10 cents? No one? It's like I asked Marco yesterday, and he's at 10 cents. So you're all smarter than him. That's good. All right. Again, it's a tricky question, so you probably expected the trick and say, oh, okay, I won't say the obvious answer. The answer is, let's do some math. And bat is $1 plus a ball, so it means that 2 balls plus 1 equals $1.10, and the price of the ball is 5 cents. This is an experiment of psychology. So people from Stanford and Eton and Oxbridge were asked this question, this puzzle, and more than 80% of them answered 10 cents. So I see people here, I'm a lot smarter than that. That's awesome. But we get back to the reasons behind this answer later on. So I'm just going to continue about other things, if my slider works. So, simplicity. What is actually simplicity? Simplicity is quality or condition of something being simple by design. So it's not something that you do, it's just an attribute of an object, or attribute of a system, or attribute of a problem. In contrast, simplification is something that is, well, simplification is the process of making something simpler than it is. So you take something complex or complicated and make it simple. And this is what I don't like. I'm going to tell you a story. And the story is about the space pen. You probably know it, some of you probably know it, but I didn't know it, so I find it fascinating, and because many times it's given as an example of not make things, complex things, simple things complex. So the issue is writing in space. Well, the problem is that the traditional pens with the ball, they don't write in space because there is no gravity. And you need to have gravity on ink in order for ink to go down and actually produce something. So the history goes, the urban legend says that space pen was designed. NASA ordered space pen design. The private company spent $1 million designing it in research and development. And it actually uses some complex ink. I can't even pronounce the name of it. And it uses pre-pressurized ink cartridge, so you don't need the gravity. The pressure inside the cartridge actually produces enough pressure on ink in order for it to go out. It's actually really sealed hard ball, so there is no unneeded or unwanted output of this pen. But the story goes further. Clever Russians say, just use pencil. That's so easy, so simple as that. And this is the package of a pencil that you can actually buy. Well, so for every problem that is, for every complex problem, there is an answer that is clear, simple, and wrong. So the quote is often, the quote is said to be, well, how do you say it in English? Prescribed? No. People say that Mencken said it, but he actually said something else. It's much longer quote, but the essence is the same. Simplification looks like this. So find x, and here it is. We're trying to make something that is in nature complex. It has a complex nature. Try to oversimplify it to the degree that it actually makes no sense or makes very little sense. And we have this blue versus red pill choice. Every time you're facing a complex problem, you can either say, okay, I want to take red pill or the blue pill. So simplicity and simplification, although they sound the same, they're actually in contradiction. Simplicity is something that you can actually maybe bring by your design. So you make your design in a way that your system will be simple to use. But in order to do this, you might spend significant effort, and the system that you're designing will be very complex. So let's look at pencils. Pencils are messy. Can you do this in space with no gravity? Probably you don't want it. Pencils break. What do you want in space? Breaking pencils? No, you want reliability. Pencils also burn. And that's definitely not something you want to do in space. So the real story is that NASA also tried using pencils, and it actually worked to some degree. And the space pen was delivered, researched, and developed by a company, Fisher Pens. And they really spent $1 million, but the spending was completely private, so NASA didn't sponsor them. They did it on their own. They still sell it. And NASA ordered first pens for $6, which is not a tremendous price, as Urban Legend says. And actually, Soviets also ordered the same pen. And so the pen was used on Soyuz, it was used on Station Mir, it was used on Apollo missions, and it's still used on ISS, International Space Station. So, in fact, astronauts and cosmonauts, they use a combination of pens, pencils, and some special markers. So this is the picture in the museum in Vienna. This cosmonaut Leonov is testing the Fisher pen and writing the message of peace in 1968. So there is essential complexity. And essential complexity is that there is zero gravity, and that's obvious. But in addition to that, that's something we've been missing when we said pencil is enough. It's not just zero gravity. It's contamination control, so you cannot produce any dust. It's reliability, so it cannot break. It's quality of record, so it needs to produce sustainable writing. Pressure, so it should work, well, probably pencils work under pressure as well. And the temperature. And temperature is very important because things should not burn on the space station. So I give you one real-world example from something I did recently. The use case is very simple. We need to add new users to the system. That's a very simple thing, extremely simple. So what do? All right, create user, boom. We create users table, roles table, and we put some role ID, varchar with 225. So of course, we don't expect people to have long names. That's fine. We display a name. We display error message like your name is too long, invalid name. But that's fine. So we can live with that. But the thing is that in addition to create a user, we also have a little bit more complexity. So our company does only phone sales. We just recently started to sell online. The phone sales mean, essentially, that we don't know email of the user. We don't know their telephone number, and some telephone numbers that they give us are not mobile. Some telephone numbers that they give us are incorrect. And the only thing we really know is their delivery address. So what is the solution? Right? We create a user, we generate a username, we also generate a password, we print it out and send it as a welcome letter. So far, so good. So we expect a happy user to receive our welcome letter. Welcome to our brilliant system. You paid us a lot of money, and this is your username and password. In reality, the user gets tons of mail, bills, spam, and some welcome letters. So what happens with welcome letters? What do you do with the welcome letters? You dump them in trash, not even opening them sometimes. The result is unhappy customer, and of course, unhappy customer support that comes to you and says, what the hell have you done? In fact, we try to measure this, and some customer support agents say up to 80% of the support calls are about this. 80% means that like they get maybe 5,000 calls per day, maybe a bit less, but those 3,000 calls or 4,000 calls are completely unnecessary because we designed a bad system. We said it's a simple thing to do. We just create things and send them over in the welcomes letter, but it turns out to be a complete disaster. So where am I going with this, actually? Here. Professor Snowden delivered a brilliant keynote yesterday talking about Cynefin framework. And there is a little issue. There is not that much information about Cynefin, but if you start looking and watching videos, you will get this. So this is a screenshot from a video. It's fine. 3, 4 quadrants and something in between, something black that has no name. Something like this, 4 quadrants, something in between again. Something like this. This is actually correct, right? Something like this. All of them look nice. So basically simple, complicated, complex, and chaotic. Except the original picture looks like this. And anyone sees something that is not right on the previous one and it's correct here? It's basically this small thing. And this small thing is very often missed. This small thing means that there is, in the original paper, it says complacency is something between simple and chaotic. Complacency is a new word for me. I'm not English native speaker, so I didn't know what to think about it. It's basically this. It's a feeling of uncritical satisfaction. It's something where you sit in simple, and you, like that dog on fire, you know, say everything is fine. I'm okay. I know how to deal with this. And this is perfectly fine, and I don't need to do anything else in order to resolve the situation. So this complacency is in between simple and chaotic. As soon as you get complacence and you think about something that you do as a very simple thing, you have a very good chance that after sitting there quite a long time, you find yourself in a chaotic domain. This happens because, like, imagine we have less customers now, we have millions of customers, and we did this thing, 80% of them complain about login name and password, so how many unhappy customers do we have? It will be a complete disaster. And well, we realized this before we actually went to chaotic, but we somewhere one foot already there, so it becomes more critical with every single day. So therefore, we started to redesign the system. But the reason for that, for complacency, lies in our cognitive thinking. Our brain is very much biased. And developers are very biased as well. We have a lot of experience. We have done things in the past, and they seem to work. And we tend to find patterns in things that cannot fit in those patterns. And we try to apply wrong patterns in the wrong place, because we are just familiar with that. We know how to do stuff, and we know how to do stuff well. And sometimes things look like, you know, the saying, if everything you have is a hammer, everything else looks like a nail. And it's like, you're doing SQL Server for everything, or you're doing event sourcing for everything. I'm a fan of event sourcing. I'm doing it for everything. So, have you read Kahneman's book, Thinking Fast and Slow? Anyone? Cool. It's getting more and more people to this. I think it's a very interesting book. If you're a developer or architect, I think to understand how your brain works, it's a very good book to read. And Kahneman divides. It's not his observation. He just summarized stuff in the book. He's a Nobel Prize winner. He divides thinking in two categories, fast and slow. And fast is something that we do unconsciously, and slow is something that we really need to think of. So we engage what he calls system 1, which is based on emotion and biases. And system 2 is really real thinking. But the system 1 is very fast and very efficient. And in order to save energy, our brain prefers to work with system 1. So when we make decisions, sometimes people come to us with a paper and say, look, I have this problem. And we say, yeah, I know how to solve it. In fact, system 1 told you how to solve it. So you made a decision about a solution before even start to think about the decision-making process, without engaging the system, the decision-making process. So, as Linda Rising said, you made a decision. They observe your brain in an MRT machine, and you made a decision without the decision-making part of your brain even coming online. So, the principle that Kahneman postulates in the book is what you see is all there is. And this is something that actually prevents us from making proper decisions. So, as you can see, the ball price is not on cents, although system 1 tells us it's exactly like this. So we see $1, 10 cents, $1 less, 10 cents left. Very easy. System 1 thinking, wrong. Requirements lie. Requirements people talk to customer, they probably have multiple transitions between real customer or real users, their representative, talking to our business analysts, talking to architects, talking to someone else, requirement analysis, and then go to developers. And the meaning of these requirements gets completely misunderstood. And every step, every person in this step has their own biases. And they actually can make requirements in a way that the solution that you probably make based on those requirements will be not resolving the problem. I should put a picture of Dr. House here. The domain experts don't tell you all the truth. I wanted to write lie, but it would be too harsh. They are just unconsciously not telling you all the truth because they say, okay, that's a simple thing. You know, I do it every day. It's nothing complex. Just do the thing I want, and I will be fine. We are too fast in making decisions because we are under pressure, we are under stress, we have deadlines, we want to satisfy our users, we want to satisfy our bosses. We just do that. And fast thinking prevails. The system 1 actually delivers most of the software we do, I think. When you write code, I think system 2 is actually engaged. Because you start to think, how I do this, how I do that. And we actually prefer this kind of problems. We don't want domain problems. We prefer to solve technical problems, but ignore the essential complexity. So there are several biases that I think are very important in order to understand how we make decisions. And first is a confirmation bias. It's like see no evil, hear no evil. When people like something, and usually we like our first decision, they perceive all information that confirms this as true, and they perceive all information that is not confirming this as false or not important. It's very comfortable. So it's like political views, you know, like religion. People just tend to ignore, overhear, or blame the sources of information that don't confirm their visions. And this happens also with system design all the time. If you design something and you think it's good, you try to defend it with all forces. Also, you might already know that it's not that good. I don't know about you, but I observe it in myself, in my colleagues all the time. But it's important to realize this bias in order to fight your enemy, you need to know it. And biases are your enemies in this sense. Overconfidence is another bias. Who of you have delivered a project that was over time and over budget? Almost everyone. And this is because we are overconfident. When we deliver something, when we talk to domain experts, when we talk to people that are ordering features from us, we give estimations to them. Oh, I do it in 2 weeks. That's fine. I know how to solve it. Yeah, that's okay. Then you start to code. Then you discover some accidental complexity. But this you can solve. Then you deliver something, and oh, no, that's not that good, because you were under the confirmation bias, so you designed not the good solution, and then you start to do it again. It's good that you have iterations, but imagine you do it in waterfall. It's like you spent weeks, days, or months and years trying to do something just to find out that it's not the right solution for the problem. But overconfidence is not only about estimations. Overconfidence is also about being confident solutions that you design. Eric says, and many DDD practitioners say, throw away the model. The problem is that as soon as we design a first model that more or less fits to the problem, we stick to it. We love it. We spend so much time doing it because system design is not an easy part, not an easy task. We spent days, maybe weeks doing the design. We did event storming. We did everything we want or we need. And then we love this model. And someone says, throw away the model. Say, what? No, it's perfect. It's very good. It solves the problem. Well, maybe it doesn't. Maybe you need to overcome this bias and try again. And I would suggest, instead of trying to make the ideal model from the one you have, because definitely not all models are ideal, they need to be crystallized, they need to be worked further on. Try to create more simple models, but several of them, but when you're doing it, have a break. I personally don't believe that you can do 3 different models within 1 modeling session. They will be very much alike. And that's the problem, because you got this anchoring. You like it. You start discussing the thing all over again. You say, we are going in circles. Let's stick to the first model. What's good enough? So maybe it's a good idea to split people that do the design in several groups. Ask people that are not in this domain, they never participate in discussion, to have a look. We had a perfect experience. We were discussing thing in a group, and we invited one of our colleagues, who is here, to participate in event storming. And he started to throw ideas. What's that? Well, this is that. What's that thing? It doesn't make any sense. Yeah, probably doesn't. What if you do this thing? I said, oh, this makes a lot of sense. So we actually remade the model completely, just by having external in the group that has no domain knowledge whatsoever. For him, the model that we designed didn't make really much of a sense, and then explaining the model to other people, we learned a lot of insights. And ideas that we got stuck to without confirmation bias, without anchoring, and with our overconfidence actually affected our thinking very much. A group of smart people really wanted to solve the problem. We went through asking all these questions, but we're still overconfident in a bad model. The next thing is availability heuristic, and this is the essence of what you see is all there is. Availability heuristic says that the only information you pay attention to is what you have in hands at the moment you start doing something. It's like when when a shark attacks a surfer, you say, I'm never going to surf. It's so dangerous. Although in your country, people who die in a car crash, they by order of 3 magnitudes, this number is higher than people that are attacked by sharks worldwide. So it doesn't make any sense from a logical perspective to be afraid to go surfing because there are sharks in the sea, but you still do it. After the plane crash, everyone is afraid of flying. After the attack, the bomb attack somewhere, and suicide bombers, you say, I'm never going to London. But the chance, if you start to think logically, the chance for it to happen with you, it's a sad event, but the chance for it to happen with you is very, very small. So from logical perspective, this fear is not really applicable, but you still have it. And in order to overcome it, we need to seek more information than we have in hands. The availability heuristic is actually works in a way that you get some information and you read it through. You like have a problem description for something. You use a story, you read it through, and you already your brain starts working on a solution, and then you ignore everything that comes in addition to it. And it's very hard to overcome this bias. You need to deliberately spend time seeking new information, making more interviews, making more modeling sessions, working with people in order to seek more information and prevent or block yourself from making solutions before you actually have information in hand. Much more information than you have in the first place. This we hear all the time. Minimum viable product. Boom. Yagni. You're not going to need it. Keep it simple, stupid. These principles tell us don't make overcomplicated things. Make everything simple, because everything is simple around us. The world is very simple, but the world is actually chaotic. The lean startup tells us, okay, concentrate on minimal viable products. And they have these diagrams. I hate these diagrams. They're all everywhere. You have a skateboard, and the next is, this is your MVP, the next is bicycle, and the next is a car. So they expect your customer that wants a car, the first buy skateboard. Really? It's like, I want a car. I don't want this bloody skateboard. Okay, maybe bicycle will work, but at least I need something with a roof, or unless I want a cabrio. But MVP, in a sense, is a good thing. But this analogy that you start with something completely irrelevant in order to make something reasonably complex is not really going to work. You could do the user creation or user invite process simple, but it still should cover the use cases that you have. Maybe not ideally, maybe in a way that you want to improve. That's fine. But it should not be sending a letter on paper. Yagni is a good principle for technicalities. Yagni is not that good principle understanding domain complexity. Because, we create software not to solve simple problems, because simple problems are already solved, most of them. Problems that we want to solve with software are by nature either complex, or complicated, or chaotic. Because all other problems don't really need technology to solve them. Look at photo publication in the cloud. The app is very simple. The most popular app might be a little bit more complicated, but it's really not that complex. What's complex there is how to get people to use it and the social aspect. And it's all in the system design, and this all domain complexity is there, but the app is made very simple, so you can use it in a simple way. And this contradiction between simplicity of user experience, user interface, and the complexity on things behind sometimes create confusion. So people think, I will solve this problem in a simple way because this is a simple problem. No. It's a complex, complicated problem, and you might solve it in a simple way, but you need to realize the domain complexity. So this is something to avoid. Remember that from obvious domain to chaotic domain is one step. So you want this, and you get this, and you don't want it to happen. So getting back to this experience, because I haven't told it how we resolve it, well, we started to embrace the domain complexity. We say, yeah, we want the best user experience, which is simple for our users. But we have domain complexity in there, so we need to spend time on doing the design. And we realized that we are not in simple quadrant. Over there, it's okay, let's look at complicated. Complicated means that we need to look at the problem, and there probably are good practices, because the best practices that, as we saw it, they didn't exist. So we looked for good practices, and we decided to sense, and we already sensed that it's not good, what we've done, analyze, and respond. So basically, this is what we did. We look at Slack. How they did it? I think they did it brilliantly. They have this very simple screen, where you need to enter these details, email address, first name, last name, and you send invite. So first of all, people in our company don't really need to create all the users for the customer if we have such a system. They only need to arrange one user for administrator, and this can be done automatically. Of course, as Matthias said 1 year ago, or he tweeted at least, I don't know if he said it, in order to be a good system designer, you need to design the organization. If you are not influencing organization, you are not designing the system. It's because of the Conway's law. So what we had to do, we had to redesign the sales process a little bit. So they include the requirement to provide us an email address or the mobile phone number so we can send us invites. It was not huge, and it was actually easy to implement. And people were equally happy because it was almost no influence on their sales process, but it was huge impact on what we do and how we do stuff. Trello is another good example. See? I'm sending invitation to Matthias at Verizon DDD. It's fictitious domain, so you can't send this email. But it works exactly like this, with a little bit different user interface. The idea is that we shift the responsibility of creation of users to our customer. And they're actually happy with this, because they have more control. Before, we were sending hundreds of those welcome letters to every employee. So if we get a company with 100 employees, they would send us an Excel sheet. Someone would need to generate the users for them. And we had a whole logistic process around it to actually deliver these user invites, or not invites, user accounts to these users. And if 70% or 80% of those welcome letters were thrown away, we were having a huge problem. So this is what I like. Simplicity is for user experience. It's not for the background system. The domain complexity is there, but the user interface needs to be simple, so please don't do complex screens. You know this famous picture of Word, when they have screen full of buttons and toolbars and everything, and there's a little bit space there in between, which says almost no space here. So this should not be done. So the system that is presented to the user needs to be very easy to use. And then you need to bring simplicity. But simplicity is not simplification, and especially not oversimplification. Simplicity is something that you need to spend time designing. This is why user experience designers and UI designers exist. They learn things and they spend time together with users, together with you, to design good user interfaces and to design a customer journey, to design processes, even to design these welcome emails in order for people to click on a link to invite other users. So this is simplicity. Technicality can also be simple in terms of I don't need extremely complex technical implementation. But this is discussable because usually if you have a complex problem, you need to have more or less complex solution. But the simple solution would be for a complex problem to buy something. You buy a good software, install it, and people start using it. But again, this software in nature will be quite complex because the problem that it's trying to solve is complex too. That's what we did. That's one of the design session outcomes. We had a huge discussion. It's not really visible here. We put a lot of post-it notes. We tried to draw lines. We did a bit of a design. I think we had like 5 design sessions until we finally come to the solution. The solution was heavily over-engineered. The user invite process is horrible, but it's way, way better than what we had before. So I would argue that we found ourselves with this user invite issue somewhere between complicated and complex. This is because we didn't really analyze the behavior of users that would actually doing these invites. We found, for example, that we set 24-hour expiration period on a user invite. What happened then? Invite has been sent on Friday. People come at work on Monday, click on the link, invite expired. It doesn't make any sense. We actually had never have had a requirement to expire this invite because it doesn't make any sense. We steal this functionality, not to steal, we copied it from somewhere. Probably Slack had the expiration date. We thought it's a good idea, so we copied this. Slack got rid of it. At the time, we said, what the hell is going on? We tried to look at how they did it. They get rid of this invitation expire. All the revoking invitation is a very helpful function because when you invite someone, we immediately assign a license to them. So it means that if someone entered the wrong email address, they are losing the license. They couldn't invite anyone else. So we really needed the revoke function. We also needed the resend function with the ability to change email address or password or, telephone number. So if they actually made a mistake, they can send it correctly. Or if people just accidentally remove them, we can resend again, and the user will get it and react. So there were adjustments. After we stabilized the front end, which was kind of simple enough, we started to simplify the back end because it was also over-engineered. So we got rid of useless features, we built more useful features, and we designed some technical debt, that's okay. Then we started to refactor it. And it turned out to be a good process because we discovered more complexity there. We have now very technical complexity because we have 2 different products, and one is still operating with paper stuff, and another one is working with invites. So we got duplicated our user base, which isn't good. So, but this original decision to send paper letters was very simple. It was horrible. We're still dealing with consequences, and we probably will spend a whole year actually fixing it. So we started back in 2016, and we're still dealing with this, especially in the part that is in legacy system. And complexity that we definitely need to avoid is this accidental complexity. When we implemented the user invite process, and we designed a huge process manager there, a lot of events, a lot of commands, we later found out that this expiration date is completely unnecessary. We were also assigning licenses prematurely, and we were also not creating users before the invite is accepted. So it was really complex. And then we started to simplify it and decrease the degree of accidental complexity. But it still was much better to make it in a way we did because it actually solved the user problem. The simplicity of user interface and user experience was still there, although The accidental complexity level was too high. But accidental complexity you can remove. However, if you bring simplistic solution to the user which doesn't work, you have to deal with this, because this is real people, these are real customers paying you real money. They probably won't pay you money if you do it wrong. If you really deliver a simplistic solution that doesn't solve the problem, they don't want to pay you. So therefore, I think the risk of accidental complexity is much less than the risk of unneeded simplicity. Another example that I love is reports. Reports are very simple. We recently acquired a company in Denmark that has a very simple, the main thing is like they track vehicles, they have devices on every vehicle they have contract with, and these devices are sending them positions. They create trips from these positions, so it's movement from A to B for tax reporting. That's actually our core business, one of our core businesses. So that was our competitor, we bought them, we look at the software. So they have this little feature in domain complexity, essential complexity, but it's solved very simple way. And they decided to solve everything else in a simple way. So everything they have is a report. Who was speeding at that day? It's a report. Who was driving the car after working hours, which they are not allowed to do? It's a report. Who was driving over mileage? It was a report. So report they built a comprehensive report generator, and every feature the user asked them to make was actually a report. So when the user comes to them and say, I want to know who was speeding at the day. Oh, we need a new report. That's brilliant. So what the users need to do at the end of the month, they need to go to the system and say, I want that report. And they had 120 reports. That's very convenient. What users really needed to know or needed to have is to be notified when someone was speeding. That's it. That's a simple reactive system. You detect the fact that someone is speeding and you send an email or SMS to the administrator. And because our company is a little bit more mature, we have done it this way and we have a high degree of customer satisfaction. Actually, instead of looking at the reports all the time, they just go on notification setup screen, set up those notifications that they want to receive, and it's done. Udi Dahan, in his advanced service-oriented architecture course, he says users don't really need reports. They think the report is what they need. Because usually, remember the old times, the old days, financial report. They print it out, or they were written by hand. They pack it in a file, and the secretary will bring it on a table of a CEO, or CTO, CFO, sorry. CFO. What he does, he opens this file and starts to look at the figures. And what he's looking at the figures is not like he's doing mathematical calculation. He's probably, or she is probably comparing the figures with yesterday, or last month, or last year. It depends on what kind of report is this. So what they're really looking at is a difference. It's something unusual. They have patterns in their head that allow them to discover some fluctuations, something that they need to react. So instead of doing the report, it's much more convenient for them if you design a system that would use some sophisticated algorithm that will be kind of complex in the nature to find these deviations, to find the things they want to react upon, instead of them spending time analyzing these reports. And the risk is very big that your business analyst will come to you and say, yeah, you see, a customer wanted a new report. And this happened to us. We got a customer, potential customer, very big. They say, we need to know, we want a report. Actually, this customer, that's what the customer said, not even business analyst. We want a report that will show us when, which unit, on which equipment, went out of the geofence area and went in back. Okay, report, fine. We made a report, spent like 3 months doing this. Because we never had this kind of report. It's all transactional database. We need a reporting database. We create additional load on our transactional database. We put indexes in there. It was really quick and dirty. A couple of months, 3 months spent. One more item in this old reports view. When I talked to the business analysts and I asked them what the customer really wanted to have, they said basically they want to be notified when the unit leaves the geofence area and never comes back, or they want to know how many units are actually within geofence area, so they keep track on them. Why have they asked for a report? The answer is very simple, because they always done it like this. Because they physically have a road, that's a railroad, that doesn't change, from A to B, and there are several of them, and there is a geofence area around some city. And what they had a man sitting on each edge of the geofence area, writing down all these cars, railway cars, that pass in this border. At the end, they would compile all these writings into one report and bring to the table of Big Boss to look for deviations. They were actually looking for lost cars, or cars that went in a direction they don't supposed to go. Our system with automatic tracking of vehicles could have solved it much more efficiently, automatically, providing good user experience. But instead, what they ask us to do is to replicate the existing functionality they already had, that it was manual, to be semi-manual. And actually, this easy part of collecting information, so it was completely automated, but they didn't want to go any further. They didn't want, because they didn't know about it, they didn't want to actually remove the reporting part. And we, instead of telling them, look, we can make it better. We don't need to spend time, because the report was that thick. And of course, it was needed to be real time, because they print it out and look at it next day, so it needs to be really consistent. Real-time reporting. So, yeah, the feature was never really deployed, because we never got the customer. But the idea is that using reactive system methodologies or design principles, we could have built it in much faster, spending less time on communication with customer, bringing much less accidental complexity to the system. Because reports in nature, they sort of people do it by copy-pasting stuff, or they have sophisticated report generator. But they produce tremendous load on the database. You really need to do stuff correctly in a separate database, maybe having a warehouse database in order to do it fast and efficient and really real-time, things like that. You need to build new read models and stuff. So accidental complexity was kind of high, but the problem was that we didn't realize the domain complexity. We missed the point completely. And with the report, it happens very often. Another example is the hierarchy. This is something we implemented too. Users or employees have a department, and department has a leader, which is also a manager, which is also an employee. We have this recursive relationship. And nothing works better in SQL Server than recursive relationship. 3 levels of recursive relationship and your SQL Server is dead. You need to put new server, or you need to put a couple of more processors, you need to put more memories there, because relational databases are not designed for recursion. So, yeah, simple solution for a complex problem. It was not like this. Actually, the model was much more rich. And it was not even, we didn't even do the discovery of the main model. We had similar structure for products and features and additions and all that stuff that we need to sell. So we have packages. Packages contain services. Services contain features. Some features have add-ons. And what happened is we had structure like this. And we didn't have even this relationship. So we had just a list of items, and they had some relationship. And we allowed people to do whatever they want. And what we end up with is an application, an iPad, and people fill out stuff like, I want to sell this item and this item and this item. But they probably don't belong together, but I don't know, because I'm just a salesperson that's supposed to sell. They also write in the comment field that I want this and this and this to happen. They also need a new report. Then it comes to the order people. We had a team. We still have a team of like 10 people that looks through these comments. Call the customer, sorry, we can't do that. Sorry, the salesperson actually lied to you. So we probably sell you something else. And they put all these dependencies right because they know how it works. So what we did, we say, oh, that's a simple thing. Oh, well, the complexity is probably there. Let's hire 10 people to deal with this. Very clever system. So what we ended up with later on, because we again felt like we are going from obvious to chaotic, because the sale process was so tedious and we need to hire more and more people to actually deal with the orders, that we started to do design session to discover essential complexity. This is one of the outcomes of this session. You see, this is just a simple one. And we had twice or 3 times more complex diagrams. And we tried to discover this relationship between different things in our product portfolio. This turned to be a very complicated problem. It's not complex because it's artificial and it's under our control, so there is no deviations there. But it was bloody complex. Oh, sorry, complicated. I should avoid complex. It was complicated. We spent days and days and weeks talking to different people, talking to Salesforce, talking to people that are doing accounting, talking to people in logistics, how they deliver stuff, because product can be delivered because this is a physical product and product can be delivered as a software. And the product that's delivered as a software can be delivered immediately when the customer pays. And product that delivered, and then we can start billing them. Products that delivered by mail needs to be delivered first, and we need to get a confirmation, then we can start billing them. Lots of stuff. How to do a good user interface that will allow for people to structure new packages. Where is the bounded context? We found out that the pricing is in marketing bound context. And the product catalog is somewhere in logistic bound context. And the whole sales thing is in sales bound context. And what we did have is something like this. And it didn't work. So I'd like to finalize this talk with reminding you what domain-driven design is. It's tackling complexity in the heart of software. We are trying to solve complicated and complex problems, and I really assure you that simple and obvious problems rarely exist. Because life is not easy. Life is complicated. This is a misquote of Albert Einstein. Everything needs to be as simple as possible, but not simpler. It's not what he said. But basically, that's a very good quote. And there is, of course, a picture of a globe for no particular reason. Thank you very much.